Welcome to the second video of data engineering playlist. In this video, we will be discussing about the fundamentals and characteristics of cloud computing. Let's get started. Let's understand the fundamentals using these 5 points. First is concept of region. Whereas in my previous video, I just mentioned that whenever we save any file in Google Drive or iCloud, it actually gets saved in a specific location, in a physical location somewhere. But the question can come, how do we actually come up with that physical location where we want to store the data? That's where the concept of region comes into the picture. Let's understand with this definition. A specific geographical area where cloud providers operates data centers to host cloud services. Basically, it means to say there's a geographical area which is decided, and there from there we have the data centers to store and process the data. If you can see from this picture, we have region 1, we have region 2. Let's understand region 1 as India. For now, India is a country, and let's understand it as a region. India is a region, and it has three what availability zones. And we will understand it further, but for now, let's go to and understand why need regions. The question might come that we could also save, we just have to store the file, it process it, but we could do it from anywhere. Why to decide? Why do actually decide from where do we need to keep the data? And why need regions? So, first reason for having this is reduce network latency. What do I mean by that is, suppose you are using Amazon app and you are searching for laptop, right? You search for laptop. Now, if the network latency is low, then the page will load faster. If the network latency is high, the page will take some time to load. And the second is to meet data residency requirements. Every data is different and it has a specific requirement. So to meet those requirements, we need regions. Third is regulations. Data security is a big issue, and every country has its own regulation when it comes to data. So to meet them, we need regions. Okay, let's understand regions further by understanding this availability zones in the next slide. What is availability zone? It is a separate location within the region. And now this availability zone can have one or more data centers. As I told you earlier, the file gets saved in data centers only. Let's understand India as a region, and India has three availability zones. Let's understand it like Delhi is a state, and here that can be first availability zone. Second is Mumbai. Third is Jaipur. And these three states then can have multiple data centers. But the question may come, why we actually need zones? We could just do it randomly, right? We could build data centers at multiple places. Why we need so much structure? The answer to that is to minimize downtime. We chose a availability zone. Now it has multiple data centers. Suppose for some reason one of the data centers stops working, so that would be a big issue. And to counter that, we kind of build data centers very near to each other, such that if one data center stops working, we can still fetch the data from another data center to deal with data loss. Because for any reason, it can happen the data got lost. But if this availability zone, and if it has data centers which are near to each other, there's a high possibility that the same data can be retrieved from another data center, which is a good part. Talking about the structure, each region has three or more zones. This is an optimized way to do that. Each region can have three or more zones, and these zones are connected with fiber optic networks. Yes, why? Because we would need to transfer data from one zone to another, and for that we have multiple fiber optic networks. That was one concept. Let's look at the advantage and other things. First advantage is scalability. Um, Ability to increase or decrease resources according to demand. Yes, that's a big advantage. First example is Amazon Big Indian Festival Sale. In suppose in random day, the Amazon traffic is 1 million. Okay, 1 million people are using the app. But when there is a sale of any kind, the traffic would be comparatively higher. Suppose 10 million, 20, 50 million are people are using the app on that day. The traffic increased suddenly. Now, Amazon, what it will do is it will take the help of cloud technology and increase its server or the details or anything. And then it will need the technology to run the app smoothly. Second example is any popular event, basically. Suppose India Pakistan match is very popular and it's getting streamed in I think Netflix. So what can happen is, suppose on any random day the traffic would be would be around 1 million for Netflix, but if there's a Indian Pakistan match, the traffic would be comparatively higher. And for that one day, and to run the app smoothly, we will need the help of more servers, and in that cloud technology would be very helpful. Let's see a scale. What exactly is scaling up? Scaling up is nothing but when we scale up the resources. That's it. For a specific days. When we scale up the resources for specific days, that thing is called scaling up. And here I have mentioned, see, there are two kinds of scaling, vertical scaling and horizontal scaling. Okay. Earlier, what was happening is we used to do vertical scaling. Vertical scaling happens in when we need just in one server only. We do not need another server. What we do, we increase the size of RAM, CPU, hard disk. Suppose the RAM size is 4 GB, so we can increase it up to 32 GB, and we can increase the CPU size, and that's called vertical scaling. But many times the data is so much that every machine has a limit, so it cannot alone handle all that data. And then here comes the horizontal scaling. Horizontal scaling is basically increasing the number of servers. The horizontal scaling can handle a lot of data because we actually increased the server, we increased the machines. So this is very helpful, and our cloud technology is based on horizontal scaling as of now. Moving on to the next advantage, geo distribution. Organizations or companies can rent cloud services in any region to provide services to users with minimum network latency. Yeah, so what do I mean is, yeah, same example. Suppose you are using Amazon app, you search for laptop. Okay, I want laptops, and it starts showing the laptops. But whenever using any app, you would want that the page should load faster, and that's called network latency. Network latency is basically delay or time taken for the data to reach from one point to another. Here, suppose I'm using the PC. I searched for laptop. It's taking 748 milliseconds. The data center, then data center replies, and it takes 653 milliseconds. Network latency is 653 plus 748. That's 1.4 seconds. Suppose the data center is very near to me. Now, if the data center is very near to me, the time taken would be very less, and the page, right, and the request would be accepted faster, and the page will load faster. So I would really want it, and that's the another advantage of cloud computing, that minimum network latency is achieved. Third advantage is agility. Cloud computing enables organizations to access services quickly. What do I mean? Suppose any company decides that it wants to increase the server or their capacity, they can have the service in minutes, and they can then change. Then they can adapt to new demands or requirements that are coming. Another is cost effectiveness. It has two models. OPEX model, if we see, it is just pay for cloud services. That's it. How does it work? Whenever we have a subscription, it works. And suppose you have a subscription, suppose Netflix, I'm watching, same example. there's a spike. I know that there's a cricket match which is going to happen, and the traffic is going to be very high. I can just opt for OPEX model and pay for that one day increased server prices. Second is CapEx. It involves large upfront investment, and organization needs to buy everything. Yes, they need to buy VM, they need to buy networking and everything. If we consider and compare these two options, we will see that OPEX is best whenever there's going to be a sudden increase in demands. It is optimized. Now the question can come, why does not these big companies build their own data centers? The thing is, they must be good in their business, but they are not very good in building data centers because it needs a lot of maintenance and then installing maintenance and finding a good place to keep it. So there's a lot of work out there, and this seems to be a better option. At least for startup, it's the best option because here we do not need to worry about infrastructure. Let's move on to the next point, which is challenges with cloud computing. As we all are aware, these two are the main challenges. First is data security. Why data security? Because data is very important. It helps us to find the pattern or behavior of consumers of any place. Now, suppose Indian government would want that their data should not go out of their country. And for fighting this data security challenge, these big companies like Azure, AWS, what they can do is they can build data centers in India only to make sure and to make Indian government believe that the data is not going out of the country. It's in their data center only. So that's the first data security challenge. Second is data loss. Data loss is also a challenge because whenever you are trusting someone with your data, you will want that the data should not get lost at any cost. So those are the two challenges. But as I told you, if you also saw the structure and how the process works, these two challenges have been overcome. Next is types of cloud. There are three types of cloud basically: private, public, and hybrid. What do I mean by private cloud? Suppose there's a big company and it just wants to take control of the data completely, and they do not want and they don't trust anyone. They have a big budget also. They can choose to build their own data centers. Second is public cloud. That's what we talk about: Azure, AWS, GCP. They all are public cloud. Whenever there's a company and it gives data to some other cloud platforms, it relies on cloud platforms for data security. That means they give their data and they believe on encryption, and that's the cost effective way. Third is hybrid. That is combination of private and public cloud. It is mostly because of the regulations, because government wants that some of the data should not be shared with the cloud platforms. And this is also a cost effective model where some of the data is kept in a private cloud while the other data can be given to the public cloud platforms. Okay, next point is types of cloud services. There are three types of cloud services. Let's not confuse between the two. That was types of cloud. Okay, that's a type of cloud. Now this is types of cloud services that any platform would be providing. First is infrastructure as a service, platform as a service, and software as a service. Let's see it using this particular diagram. First is infrastructure as a service. Okay, this is mostly for admins and architects because you are taking care of entire infrastructure, how the data will flow, where it will store, how the processing will go, everything. Second is platform as a service, which is for app developers. The third one is for software as a service, which is for end users like Gmail, Office 365 that do not really need, we can just log in and use it. Let's understand these three services in detail. Infrastructure as a service offers on-demand access to fundamental computing resources such as virtual machine, storage, networking, etc. Here, as mentioned, this provides the service and access to entire infrastructure. Whatever you need, they would be providing it, which includes virtual machines, storage, networking, processing power, etc. Second is that platform as a service, which offers access to complete development and deployment environment. It includes everything to build, test, deploy, manage, and update applications. Suppose you're a developer, then you will be opting for this platform as a service. Third one is software as a service, which delivers easy to use application software in internet on subscription base, such as Google Meet. Now, the question arises that a person can either opt for infrastructure or platform or software as a service according to their utility. Suppose I'm just a person, I'm a non-tech person, I just want to see and use a software I can use for this SaaS. And whenever, suppose I'm a developer, I just want to write code and don't need to worry about much about the infrastructure. I can just opt for this platform as a service. But if I'm an admin or architect, I would want to, have control on the pipeline or the infrastructure of it. So I would be opting for this particular subscription, which is infrastructure as a service. So here in this video, we discussed 5 points. First is concept of region, to understand the process of how and where the data is saved. Then the advantages of cloud computing, scalability, geo-distribution, agility, and cost effectiveness. Then we understood challenges with cloud computing, data security, and data loss. Then the types of cloud, public, private, and hybrid, which is chosen according to the need of the company. Fifth and last is types of cloud services. Basically, infrastructure, platform, and software as a service that a company can choose according to their utility. So those were the points. And let me know if you have any questions.